All right, so let's talk about interpreting the derivative. Because like I said in the last couple of videos, it's very important to understand um, kind of the concept and the idea that we're talking about here, not so much just being able to get the answer, although that, of course, that's important, but understanding what the answer is representing is also important. And I think it will make things easier as we go along into these next chapters and get to more complex functions and their derivatives. So the derivative, like we said in the last one, it's the instantaneous rate of change. That's really all it is. Or we could say it's the tangent line at that point, whatever point you're looking at. So the slope of that tangent line is equal to the derivative. And so we can kind of see, we just have kind of visual pictures here for the two different ways we can think about this. And we've kind of talked about these, so I won't spend a lot of time going through these graphs, but they are there if you want to kind of study those. So let's find the equation of the tangent line for the parabola in the last example. And actually, if you go back to that last video, I said, so part B, we found f prime of a was 2a minus 8. So if we want to find the equation of the tangent line where x is 3, if you find this, you really just have to plug in 3 for a. So, from previous sample. So if you go back in the notes, and it's on that one where we worked through this one in the last video. So f prime of 3 is -2. So that is our slope. And then we have the point 3, -6. So if we want our tangent line equation, it'd be y minus -6 equals -2 times x minus 3. And really, that's it. Again, I think I said this before as well. Web design's not too picky. If they just tell you to find the equation of the line, you don't really have to simplify it. So we won't simplify that. But that is the equation of the tangent line. Maybe the first couple times you do these, graph the parabola graph that and on a calculator on the website, and then graph the tangent line, and you see how they are related. And it's also a good way to check. You can check yourself doing those. Then, so the last part, applications of the derivative. So this is just one. There are other examples in the homework of applications. But if we have this function f of t, where it gives the position of an object that moves along a line at time t, then the derivative is the rate of change of the displacement with respect to the time t, or in other words, it's the velocity. So if we're talking about position, the function is representing position, the derivative would be representing velocity. So the position in meters of an object is given by f of t equals 1 over 1 plus t. T is measured in seconds. Find the velocity and the speed. And the only difference between velocity and speed, velocity is speed with direction. So we'll see. There's not too much difference in how we're going to solve this problem. Basically, we need to find the derivative. We need to find f prime of 2. And so we can say the limit as x approaches 2 of f, or I guess we should say t. We're going to be correct here. So let's say f t approaches 2, f of t minus f of 2 over t minus 2. So we have the limit as t approaches 2. We have 1 over 1 plus t minus f of 2. That would be 1/3 over t minus 2. So now let's find a common denominator. So 3 times 1 plus t would be the common denominator up there. So we have 3 minus 1 plus t over 3 times 1 plus t. And then we also can add this to the denominator. And so we'll just go up here. So limit as t approaches 2. We have 3 minus 1 plus t, so that's simplified to 2 minus t over 3 times 1 plus t times 2 minus t. So the 2 minus t and the t minus 2, that leaves a -1. So we have -1 over 3 times 1 plus t, limit as t approaches 2. And so now we can plug the 2 in for the t. So now we have -1/9. And so that is our velocity. And then the speed is just velocity out the direction. So the negative tells us the direction. The speed is just going to be the absolute value of that. So +1/9. Velocity is -1/9 because it'll be moving in the negative direction. But that's it. So just make sure, again, understand the concept of the derivative and practice these. So we're going to learn some formulas. We're going to learn some shortcuts as we go. So for now, mostly learn the concept. And then as we get into some later sections, we'll learn some shortcuts, and that's where you can get your practicing. But if you have any questions, again, this is probably the most foundational section that we're going to do. So if you have any questions, please email me.